Hi everyone and welcome back to Physics with Mr. Simons, where we simplify physics and we get you exam ready. Right, so today's lesson is on electromagnetism, right? Grade 11, taken the grade 11 November 2016 paper. This question for our magnetic flux linkage question, you are required to determine the area of a circle before you can get the magnetic flux linkage. Right, so let's look at the question. Question 9. They say a circular coin with 250 windings or turns and a radius of 0.04 meters is rotated clockwise inside a magnetic field with a field strength of 3.2 Tesla. So it's rotated clockwise and the magnetic field strength there from north to south is 3.2 Teslas, and around this coil there's 250 windings, right? Now 9.1, calculate the magnetic flux through the coil at the position indicated on the diagram, where the coil is perpendicular to the field for 3 marks. The coil rotates clockwise through 25 degrees and the potential difference induced, or voltage induced, is 2.8 volts. Calculate the time in which this rotation took place for 4 marks. Which law can be used to explain the phenomenon described in question 9.2? Name and state the law. If the circular coil is replaced with a square coil with a side length of 0.04 meters, the same movement is made in the same amount of time. Will the induced EMF be the same as, larger than, or smaller than the circular coil? 1 mark. And then they want us to explain the answer to this question 9.4.1 for 2 marks. So as I've stated before, always pause the video here, try to attempt to answer as many questions as possible, and make a note of your errors, and then go to the solutions so that you can practice those errors out of you. Alright, so let's look at the first problem. Right, so calculate magnetic flux through the coil, position indicated where coil is perpendicular to the field. So circular coil, 250 windings and a radius is rotated clockwise inside a magnetic field of 3.2 Tesla. So assume you remember magnetic flux linkage equal my magnetic field strength times my area cos theta. Area for circle pi r squared. So radius they gave us 0.04 meters. So there it's going to be 0.04 squared times pi. My magnetic field strength 3.2 Tesla and cos 0 degrees, right? And that there would give me 0.016 Weber or Teslas per meter squared. 1 for correct formula. So another mark for correct substitution and another mark for correct answer. Now if the coil rotates clockwise through 25 degrees, so it started from 0 to 25, the potential difference induced is 2.8 volt. Calculate the time in which the rotation took place. So again, EMF equal negative n, my number of turns, change in magnetic flux over change in time. So E equal 2.8 volts given, negative n, my number of turns were given as 250 there. We have 0.016 Weber. But the first one is cos 25, the second one is cos 0. So cos 0 is 1. So if we subtract and we punch all of this in together, I get a change of time of 0.136. Right? If you rounded that off to 0.02, you substitute it in there, then my final answer would be 0.17 seconds. Right? If we use 0.021 Weber. Right, so we cater for based on what you have done. Right, let's look at the next question. So I hope you follow what I've done then. It's rotated through 25 degrees, so it went from 0 to 25. The rest is straightforward. Alright, 9.3. Which law can be used to explain the phenomenon described in question 9.2? Name and state the law. So the law is called Faraday's law, not Faraday's taxi rank, but Faraday's law. The magnitude of the induced EMF across the ends of a conductor is directly proportional to the rate of change in the magnetic flux linkage with the conductor. Alright. Now 9.4.1, if the circular coil is replaced with a square coil, the side length of 0.04 meters, and the same movement is made, the same amount of time, will the induced EMF be same as, larger than, or smaller than the circular coil? Smaller than. Right? So what happens? Remember, area is side times side. So 0.04 times 0.04. Right? And area of a circle is also r squared, which would be 0.04 times 0.04. But for a circle, we still multiply by pi, and for the area, we don't. So the area of a square is smaller than the area of a circle, with the radius equal to the side length of the square. And remember, the magnetic flux is directly proportional to the area. So the area of the square is smaller than the area of the circle, then there the answer must be smaller than. Alright, I'm happy that you're still here and you're following me and you understand. I wish you nothing but the best. God bless. Bye.